This lesson is over distributive properties and the different properties again. So in this number routine, how do you know that this expression is equivalent to this expression? How do you know that they are the same? So let's use the algebra tiles to help us. It says 2 times the quantity of 3x minus 4. So let's do another example of 3x minus 4. So here's my pen. I see 2 groups of 3x minus, and I see 2 groups of 1, 2, 3, 4. So what is 2 groups of 3x? 6x minus 2 times 4 is 8. That is equivalent. I could have done it this way. I think this is faster, more mathematically. 2 times the quantity of 3x is 2 times 3x minus 2 times 4 is. So in this number routine, you are going to come up with different ways to represent the number 16 using distributive property, addition and subtraction. So let's start with addition one. Let's try 8. Let's see if this one works. 8 times the quantity of 1 plus 1, which is 2. 8 times 2 is 16. Or I could have done it this way. 8 groups of 1 plus 8 groups of 1 plus 8 is 16. Let's try with a subtraction one. 6 minus 4 is 2. And I'll make D 8. So 8 times the quantity of 2 is 16. Or using distributive property, 8 times 6 minus 8 times 4, 48 minus 32 is 16. Let's come up with some more examples. 3 plus 1 times the quantity of times 4. 4 times the quantity of 3 plus 1. That's 4 times 4, 16. Or I could use distributive property. 4 times the group of 3 plus 4 times 1. 12 plus 4 is 16. Let's try one with subtraction. Let's think. 9 minus 1, that's 8. Oh, this one's a good one. 2 times 9 minus 2 times 1, 18 minus 2 is 16. Or 2 times the quantity of 8 is 16. So you are going to come up with as many as you can come with yourself. And you're going to share your responses with your tribe. Then students will walk around the classroom to see if anybody had something different there. So as we continue using distributive property, let's use the algebra tile model, and then we'll use the symbolic representation. So it says 4 times the quantity of 5 plus 3. So here is 5 plus 3. It says 4 times the quantity of 5 plus 3. Here's the second quantity. Here's a 5 plus 3. And here's our last one. 5 plus 3. So I see 4 groups of 5 plus 4 groups of 3. 4 times 5 is 20. Plus 4 times 3 is 12, so it adds up to 32. Could I have done it this way mathematically? 4 times 5 plus 4 groups of 3. Oh, same answer right there. Next example, let's use algebra. Well, it says 5 times the quantity of j plus 3. That's one quantity. Here's the second quantity. Here's another j plus 3. Here's another j plus 3. And here's a j plus 3. So how many groups of j's do you see? I see 5 j plus, how many groups of 3? 5 groups of 3. So 5j plus 15. If someone had shouted out 15 plus 5j, that had been acceptable. Yes, because when you add it or multiply, it doesn't matter where the terms are located. You will still be equivalent. Again, you have done it this way. Again, I'll be honest, I do it this way. 5 times j plus 5 times 3. Last but not least, we have 6. 6 minus k. 1, 2, 3, 4, 5, 6 minus k. 1, 2, 3, 4, 5, 6 minus k. So I see 3 groups of 6s minus 3 k's. So minus k, minus k, minus k is 3 k's. So 18 minus 3k. Again, I solved it using mathematics. 3 times 6 is 18, minus 3 times k is 3. So our next part of the day lesson is you're going to be given two expressions. Are they equivalent or not? So let's see. Is 5 plus 3 the same as saying 3 plus 5? Yes, they both adds up to 8. So this is yes. What about 7 minus y? Is that equivalent to y minus 7? You know, I'm gonna have to substitute the y with a number. Like, let's substitute y with 2. 7 minus 2 is 5. Is that equivalent to 2 minus 7? Would that be a positive or negative? Using add the opposite, that would be negative 5. So no. So let's try to multiply now. 10 times g is g times 10. So g was 2. 10 times 2 is 20. 22 times 10 is 20. So yes. And with division work, is 12 divided by 4, which is 3. Is that the same as saying 4 divided by 12? No. So did you notice when you add or multiply, does it matter where the term is located? No. So what about associative? Do you think it applies the same as commutative? Where you add and multiply, it doesn't matter if it's first, second, or third term. Let's see, y plus 8. This will be y plus 5. Can't add it. So we added 3, so it's y plus 8. So yes, if you do not trust me, replace the variable, substitute the variable y with 2. 2 plus 8 is 10. 2 plus 5 is 7 plus 3 is 10. So yes. What about multiply? It's 2 times the quantity of 4, so it's 24. 2 times 2 times 3, which is 6 times 4. Yes again. They are equivalent. But with subtraction and division, again, fail the test. 7 is the left term. 4 minus 1 is 3. 7 minus 3 is 4. 7 minus 4 is 3. 3 minus 1 is 2. So definitely not. What about division? 12 divided by 3 divided by 3 is 1 plus 12. 12 divided by 3 is 4. 4 divided by 3 are they? So when you add or multiply, it does not matter where the terms are located. And let's do some example of this. 5 plus 0. Is that 5? Yes. Is 5 times 2 equal 5? No. What about this one? Is 6 plus d negative 6? Is that 0? Yes, because you have 0 pairs. What about negative 5? 2, 3, 4, 5 plus 5 more negative. Would that be 0? No. And what about 5 times a fraction of 1/5? That equal 1? Again, how do you multiply fraction? You rewrite the whole number as a fraction. 5 over 5 is 1 whole. So yes, it's reciprocal. And the last thing we're going to talk about is something called factor puzzles. Some of you are maybe very good in puzzles. 10 and 15. What can you, or let's start with this one, 2 and 10. What can you divide 2 and 10 by? By 2's. So 1 times 2 is 2. 2 times 5 is 10. 1 times 2 is 2. 2 times 5 is 10. But 15, what makes 15? If I bring the 2 down right here, Would 2 go into 15? No. So let me erase that. So let's write 5. Oops, let's write 5 times 2 is 10. 2 times 1 is 2. Bring down the 5, bring down the 1. What makes 15? 5 times 3. Bring you, so 3, you bring it down here. 3 times 1 is 3. So in the factor puzzle, the top is equivalent to the bottom, and the left is equivalent to the right. Let's try another puzzle. What makes 35 and 45? Well, 35 and 45, they both seem like they go into 5s. So 5 times 7. What makes 45? 5 times 9. What makes 20? So bring the 9 up here. Bring 7 here. What makes 27? 9 times 3. Bring the 3 here. 3 times 7 is 21. So 21 is missing number. Let's practice another one. What makes 27 and 24? What goes into it? 3. 3 times 9. 3 times 8. Bring the 8 down. Bring the 9 down. What makes 40? 8 times 5. Bring the 5 here. 5 times 9 is 45. And so that is our factor puzzle.